All right. Here we got two-dimensional motion. Chapter 4, question 1. Our cat is grumpy. It pushes a glass of milk off of the table. The height of the table is 1.12 meters. And the glass lands on the floor 1 meter away from the edge of the table. With what velocity did the glass leave the table? Okay. So first off, I'll draw a picture here. A table leg, table, and here's our cup. Our cup's going to go off the table and crash down here on the floor. Okay, spilled milk. Height of the table is 1.12. Okay, and the glass lands 1 meter away. So there's our triangle. Okay, 1.12 and 1. With what velocity did the glass leave the table? Okay. So for this one here, we're going to have to use our kinematics. It's a projectile motion. It's leaving. The only thing that is affecting it is the open air and gravity. Okay, so we'll use our projectile motion. So I'm going to go ahead and make a couple of tables for x and for y. I'll need the change in x, I'll need the initial velocity, I'll need final velocity, and acceleration and time for both. So I'm going to have a lot of information here. Okay. Now I grab what information I can that was in the problem. Okay. So first off, let's look at our x. The change in x, it moved 1 meter. And it moved a meter the way I drew it here. Moved a meter over in the positive direction. So our change in x is 1 meter. Our change in y, glass started up here and it fell down 1.12. So I'm going to put that as a negative 1.12. Okay. What else do we know? Well, we don't know a lot in the x. And that's kind of our problem. But we know this is projectile motion. So we know that there's no acceleration in the x. Okay, because nothing is pushing or pulling. We do know the acceleration in the y has to be negative 9.8. Okay, so that's the acceleration due to gravity pulling the milk down. So we don't have enough to go on yet. We're still missing something. Okay, and what we're missing here is that the initial velocity of this cup, as it slides off of a horizontal table, has to be in the x direction. That's where this all started. Okay, which means the initial velocity in the y direction must be 0. Okay, so it started off with no velocity in the y, only in the x. That's how it slid off the table. When it landed down here, we had some in the x, some in the y. So final velocities will matter. So for this one, what velocity did the glass leave the table? We want to find out what this velocity here is. Okay, that's our question mark. I don't have enough information to go off of this side, but I do have enough information on this side. And the one thing that transfers is time. So I can solve for the time here and transfer it over to here. And then I'll have enough to solve. So let's try solving for some time. Okay. So in this one, the one I don't care about here is going to be VF, or V final. If I don't care about V final, I want to use, let's see, our third equation, the one that does not involve VF. Okay, that one's going to be change in Y is equal to VI T plus 1/2 AT squared. I have change in y. Vi in this case is 0 plus 1/2 negative 9.8 times t squared. Okay, so we'll take half of negative 9.8. We'll divide it to the other side. Then we'll take a square root. So that we'll have square root of 1.12 divided by 4.9, both the negatives here have canceled. Should be equal to t. Let's see what we get. Should be a small number. We get about a half a second. 4.8 seconds. Okay, so if I add that up in here, okay, I'll add it to both since I know that was both on the x and in the y. And then from here I'm looking for VI. So again, the thing I don't care about is VF. So we'll be using the same equation over here, but for x. Okay, we get the change in x is 1. We get VI is what we're looking for. And we get t is equal to 0.48. 1/2 AT squared. The a here is going to be a 0, so I know it's going to be nothing. So now I just solve for VI. And that would be 1 divided by 0.48. And we get the initial velocity had to be about 2.08. 2.08 meters per second. That's the initial velocity at which it left the table. For part B, what angle does it hit the floor? Okay. A lot of students make that triangle and they figure out this angle and it's off. Okay. This is not the angle at which the glass hit the floor for its velocity. Its velocity has to be angled over like that. It goes in perpetual motion. It's not a straight line. So to figure out that angle at which the glass hit the floor, we need to figure out both of these final velocities and then figure out what angle is between those two. Okay? So for part B, we have to solve for final velocities. So the easiest way on that one, the one I'm going to grab, is just going to be the first equation. I'm going to use the same equation on both, which is V final is equal to V initial plus A times T. So for the first one, I'll plug in VI, which we now know to be 2.08, okay, plus the acceleration, which is 0, times time. So I know that the initial and the final velocity on the x have to be the same. 2.08, 2.08. So now all I need is the final velocity on the y. If I plug that in, I get VI is equal to 0. So all this is going to be A times T, or negative 9.8 times 0.04, or 0.48. And I get a negative value, negative 4.7 meters per second. So that should make sense, because negative would mean it is falling down. It's still falling in the positive x, but it's falling in the negative y. Okay, so now that I have both of these, I can draw that out. So final velocity here is traveling 2.08, and then the final velocity here is negative 4.7. Okay. This is the angle at which it hits the ground. Okay, that's the angle that it hits the ground. So to find that angle, sorry, 2.08 should be up here. We'll go ahead and use tangent. Tan of the angle equal to the opposite, 2.08, over the adjacent, 4.7. Okay. And what do we get here? We'll have to do an inverse tan. 2.08 divided by 4.7. And we get that this theta is equal to 23.9 degrees. Okay, so it doesn't state at which angle does the glass hit the floor. Traditionally, we would have wanted this to be from the positive x direction. And what we have found is from this to this. So from the y over to here is 23.9. Okay, so we don't really want this 23.9. What we want is from the positive x-axis all the way over to it. Or we could also think of it as it comes through the floor. We could figure this angle out as well. Okay, so we have a couple of ways of doing that. It's either going to be below the x-axis or above the x-axis. So first off, above would be 90 plus this. Okay, which in that case we get theta is equal to 113 degrees above positive x-axis, if we're talking about there. Or we could look at it as this angle down here, which would be 90 degrees. So that's this angle, so it would be 90 degrees minus the 23.9, which would get us an angle of 66 degrees below positive x-axis. Okay, so it depends on which way you wanted to calculate it, and it depends on how you draw this out. Whether you want it to be 66 degrees below it, 113 degrees above it, which one you're calculating out, but it is on the same trajectory in either case.